All right, so yesterday we looked at area under the curve, right? Or in some cases above the curve, right? We always shade back towards the x-axis, always shade back toward x-axis, right? And when we do that, we get area. Sometimes that's positive, sometimes that's negative. Anything below, any area below the x-axis is negative. Any area above the x-axis is positive. Okay, so then at the end, we just add them together, kind of like we did on this problem right here. We added the green with the darker color at the bottom, and that's the area. Okay, using geometry, using shapes that we know, right? Circles, trapezoids, triangles, squares, rectangles, anything like that, right? In order to do that, though, we had to graph them. We had to graph them. It works. That works. That's the exact area. Like this one right here, -12, that's the exact area. It's not an approximation. It's not like rectangular approximation. It's the actual area. Okay. So we would say that the area under the curve from 4 to 8 for the function 3 minus x is -12. Okay. That's where we stopped. Alrighty. So example number 3, same thing. It's the same thing. They give us a piece of information though. So now we're dealing with sine. I think just sine on this one. It's a trig function. Okay. A trig function. So they tell us something. They said, given that the area under the curve or the integral from 0 to pi of sine of x dx is 2. So they've told us that the area under the curve from 0 to pi is 2. Okay. So what I'm going to do is I'm going to draw that real quick. I'm going to sketch that out because I think it's going to help me solve some of these. Okay. So sine starts at 0. Cosine starts at 1. Sine starts at 0. So I'm going to sketch the curve here. Give me 1 second, guys. All right, so I'm going to draw a quick sketch of what it looks like. Actually, you know what? Let me make these a little bit, give myself a little more room. So sine starts at 0, right? Sine of 0 is 0. This one gives us to pi. All right, so I'm going to draw the big guys. So pi over 2 is 90 degrees. Pi is 180. 3 pi over 2 is 270. And then 2 pi is 1 revolution around the unit circle, 360, right? So they say that from 0 to pi is 2 whole units. Okay. Well, you might know this, or if you didn't know it, we have our trig sheets, right? And on our trig sheets, we can kind of look at where the values are. So at pi over 2, sine is 1. At pi, sine is 0. Right? And then in between pi over 2, 0 and pi over 2 is like pi over 6, pi over 4. Like pi over 6 is like right here. And that's about 1/2. So we talked about this before. Pi or sine is a sine wave. That's the first part of it, the first half of it, right? The second half goes down here. And that's one full revolution or one full cycle of pi. And then it just repeats. It repeats itself, repeats itself, repeats itself. Same thing with cosine, but cosine starts at 1. Cosine doesn't start at 0. Okay. Okay, so Now let's identify what they've told us. They've told us at 0 to pi, the bound 0 to pi, the area is 2. Okay. Well, 0 to pi is from blue dot to blue dot. All right. And we shade, it's above the x-axis, so we shade below. And that's going to leave us this spot here. All right. Okay. And they tell us that. They tell us up here. That area is 2. Positive 2. That's given. Okay, that's the given part. Now, using that, we have to answer A, B, and I think there's a few more on the next page. Okay, so if that is 2, now they want us to figure out what the area is from pi to 2 pi. That's this stuff here. So what is the area? Let me color code this. So this, okay. So what do you think the area is going to be of the purple? Shot in the dark. What do you think the area is going to be of the purple? -2, yeah. Same size, it's exactly the same size. It's just below the x-axis, we shade up, so it's going to be -2 instead. All right? It's the same values. Like the same dots here are all the same dots here, they're just negative. They're all made up of the same dots, it's just the opposite signs. So that creates this that's the same. Okay? So what would 0 to 2 pi be? What do you think 0 to 2 pi would be? Yeah, they would cancel each other out. You add them together, you add the blue and the red, you get 0. They cancel each other out, right? There is no area. There is area, but they cancel each other out because some of it's positive, some of it's negative. Okay. Question C says 0 to pi over 2. 0 to pi over 2. So now we're focused on just the green. So 0 to pi over 2. So this area right here. What do you think that's going to be? Shot in the dark, what do you think that's going to be? 1. Yeah, half, right? Because the dots over here, right? 0, pi over 6, pi over 3, or pi over 4, pi over 3, right? They're the same values as over here. They're exactly the same values. They reflect. One side reflects the other side. So if they reflect and have the same values, that means they must be half. They must be half of each other. So the area under the curve is just 1. Okay, again, without this graph, it's not as obvious. I mean, you could do it. It's not difficult, but it's a lot easier if you have the picture in front of you, right? So if the function is not hard, if it's a pretty basic function, draw it. Okay, draw it. All right. Okay, so now let's look at D. So still sine. Still sine, right? So still the same graph. But what did they do here? What did they do for D that's different than ABC? Exactly. They stop at pi, but they go to the negative side, right? They go to the negative side. Okay, so let's go back to our picture. Okay, so what I'm going to do is I'm going to move this down a little bit because I don't have any negative values, negative pi values. I started at 0. So I'm going to create some negative. Do the best you can. I know if you drew it and you can't fit it in, just do the best you can on this one. There we go. So again, over here would be negative pi over 2. Over here would be negative pi. In between would be like negative pi over, or not in between, but negative pi over 4, right? So now what it's asking is, where do we start at? Pi, negative pi to positive pi. Negative pi to positive pi. Well, what's the sine wave do? What's the sine curve do? What is it? How does it look? Always. What's the thing about the sine wave, sine curve? Yeah, it does the same thing. It repeats itself. It continues repeating itself. Goes up, comes down, goes up, comes down, goes up, comes down. So you could predict what it's going to look like anywhere. Okay? It repeats itself every 2 pi. To the right in infinity and to the left infinity. So over here, left of 0, where is it going to go? Is it going to go up or is it going to go down? So here, is it going to go up or is it going to go down? It's going to go down, yeah. It's going to continue, right? So it's going to go down like this. It reflects itself. So if there's a dot here, it's going to be a dot here. And there'll be a dot right here. Okay. So what do you think the area of this new piece is going to be? Take a shot in the dark. What do you think the area of this new piece we have going to be? Negative 2. Negative 2. Okay. So now we have enough information to go answer the question. Question says from negative pi to positive pi. From negative pi to positive pi. All right, so let's go back up, look at the picture. So from negative pi to positive pi, we start here, end here. So that means everything in between. So we got that and we got that. So that's one full revolution, right? One full revolution. It just goes in the opposite, starts in the opposite direction, starts down instead of up. So we have negative 2 plus positive 2. They cancel each other out. We get 0. Okay. The last one. The last one I put because you're going to see one like this often. Okay. So what does that 2 do at the beginning? 2 plus. What is that 2 going to do to the picture? Nothing? Something? What is it going to do to our graph that we have, that we've drawn, that we've sketched? Is it the same graph? Is it a different graph? What is it? And if it's a different graph, what is it going to do? Yep. It's not raised. You're close. Not raised. It would be raised if the 2 was here. So if this 2 wasn't here and the 2 was right there instead, it would be raised by 2. It's called amplitude. It means it would go up to positive 2 and down to negative 2. Okay, so we're close. So not raised by 2. Let me give you another one that you might recognize. You might recognize it, you might not recognize it. How about this one here? Okay, you don't have to write this down, but I'm just trying to give you another example. X squared, right? Looks like that, right? Wait, give me a second. No, you're right. It is raised by 2. Yeah, you're right. It is raised by 2. Yeah, because I was thinking something else. You're right. You're right. So if I were to do this, what would happen to the blue? What would happen to the parabola? Or if I were to do this, what would happen to the parabola? Again, this is math 2, math 3 stuff. It's nothing to do with calculus, but remembering your translations, transformations, what would happen to those graphs? So what the blue one is this one. What would each point do here? And what would each point do here? They both have +2 in them, but they do different things to the graph. What would the middle one look like? +2 on the outside. It'd move up. Every point on here would move up 2 units. So this guy would look the same shape, would have the same shape, but it would start at 2. Same shape, just up 2. What would the green one do? It wouldn't move up. You're right, it would move, but not up. It would move to the, not narrower, close. It would actually move to the left. It actually does the opposite of what you think. You see +2 and you think, oh, positive is right. When it's on the inside like this, it actually does the opposite. So it would have the same shape, but it would move 1, 2. Let me change the color. So same shape, it's just every dot would move over 2 units. They're translations, they're transformations. Okay. Now, which one does ours look like? The red or the green? The one we're looking at right now. Does the 2, which one does the 2 look like here? Does it look like the red or does it look like the green? Because that'll tell us. Oh, we move every dot up 2 units. Or we move every dot, we shift every dot left 2 units. It'll be the red one, yeah. It'll be the red one. Yeah, like you said earlier, it's going to move everything up 2 units. Yeah, originally I got the green one and the red one mixed up, but yep. If we wanted it to move left 2 units, it would look like this. This would look like this. Sine of x plus 2. That would move left 2 units, but that's not what it is. So the 2 means every dot we have from sine of x. We have this graph written, right? We have this graph drawn already. So every graph here, every dot in this graph, the sine of x, is going to move up 2 units. So let's go back to our graph. Here's our graph here, right? This whole graph here is going to move up 2 units. What is that going to do? What is that going to do to the overall area? Because right now the area overall from negative pi to 2 pi is negative 2. If I were to move each dot up 2 units, what would that do to the overall area? What effect would it have? Hmm? Yep, there would be no negatives. There would be no negatives. Down here, right? The lowest point I have is what? Negative 1, right? Negative 1 and negative 1. If I move those up 2, they're not at negative 1 anymore. They're at positive 1. So that means the bottom is at positive 1. The top is at 1, so that would move up to 3, right? So nothing would be underneath the x-axis. So it would all be positive, okay? So I'm going to draw a sketch of that, but with these new changes, okay? Oops, right there. Okay, so I'm only going to draw from 0 to pi because that's all we need. So I'm going to draw these quick changes here. I'm going to draw the original, and then I'm going to draw the new one. Give myself some more room. Okay. The original went up to 1, down to negative 1. Right? Oops, that's not good. Started here. I'm only going to pi because it only wants me to go to pi, right? So I'm only going to pi. So we went up here. Kind of look like this. Like that. That was the original, right? Now I'm going to redraw that graph, except every dot on there is going to move up 2 units. Okay? It's going to have the same shape. It's just going to move up 2 units. So this dot, and I'll do it a different color. So this 2, 3, negative 2, negative 3. This dot would be here. This dot would be here. This dot would be here. Okay. So the red, or sorry, the blue is the whole thing. The black is the part where the original sine of x. Okay. So originally, area under the curve was right here. Right? Area under the curve is right there. Where would area under the curve be for the new guy? What would I shade here? The green is the old one, right? So now I have to shade from 0 to pi again. But, so it's the green and the yellow. I have to find the area of the green and the yellow. How do we do that? How do I find the green? Because that kind of looks like a weird shape. The green and the yellow combined. So I'm trying to find the area of this thing. Let me outline it. That thing right there. Area of that whole thing. How do we do that? That's exactly what I'm going to do. Yep, exactly what I'm going to do. I'm going to break it up into the top part and the bottom part. So I'm going to split it up right here. This is where I'm going to split it right there. The reason I'm going to split it there is because the bottom here is a square or a rectangle, right? And then what do I know about the top here? What do I know about the top? Mhm. There you go, yeah. It's the same area as the green, it's just raised. Okay? So now what I got to do is find the area of that box, of that rectangle. Well, the width is pi. The height is 2. Multiply them together, you get 2 pi. So I get 2 pi, and then the area of the top is 2. 2 pi plus 2. Okay. So you're going to see that quite a bit. You're going to see things like that where it's a translation of something you know, right? You know what sine looks like, you know what cosine looks like, but it's going to give you something like that. If it said -2 plus, that means everything moves down 2 units, right? So, um, so just be careful with those. Remember these guys here. Okay, what it means to the graph, what happens to the graph when you get translations. Okay, so last thing is calculator. I'm gonna your calculator will do these things. We can check our answers. Okay, I put some examples here, but I'm not gonna worry about the examples. So calculators. So let me get some calculators out. If you have your own calculator, take it out. If you don't, come grab one. I think I have enough calculators for everyone. And I will show you how to use them to find area under the curve. Okay, so when you turn on your calculator, just hit on, and it should take you to, once my calculator loads up, it should take you to the home screen. If it doesn't, I'll tell you how to get there. So if it takes you to anything other than a blank screen, you're going to hit second up here. It's the top. It's the, I think yours is blue button at the top left, second. And then right next to it is a quit button. You're going to hit quit, and that'll take you to the it'll always take you back to the home page, the starting. And if you have stuff in here, you can just hit clear. That clears everything. This is where you use your regular calculator stuff. This is regular calculator usage, adding, subtracting, multiplying, dividing, all that stuff. Okay. If you want to use any of the advanced stuff like finding derivatives or finding area under the curve, integrating, that's under the other programs, which I'm going to show you. Okay. Okay. So first thing is, if you have an 83, it does everything. Ours are 84s. So if you have an 83, it does everything, but it looks a little different. Okay, so if you have an 83, it works, but it just looks a little different because the OS, the operating system's a little different. The ones that we have are the ones that look like most of the calculators in there have been updated. So you're going to use these directions here. Okay. Thank you. Alrighty. Okay, so first thing I'm going to do is I'm going to go to math. First thing you're going to do is you're going to go to math. Anytime you want to find a derivative or anytime you want to find a integral, area under the curve, you're going to go to math. It's the button right under, two buttons underneath a second. So you can hit math. And then it gives you a bunch of different things. We're going to stay in math. We're going to go all the way down. You see number 8 says deriv. That's derivative. If I wanted to find derivative, we would do that. The one right below it says f of n, function integral. That's the one we want. So you're going to scroll down to 9, or you can just push 9. Oops. Okay. If it gives you something like this, it's kind of obvious what you do next, right? Because it looks like a problem. Does anyone have something that doesn't look like this? Everyone's look like this? Good. Okay, they've all been updated then. Good. Because those calculators are over 10 years old. They still work fine, but I had to update them, and I wasn't sure if I updated all of them, so obviously I did. Good. Okay. So here, let's do one of them that we just did. Let's do the one we just did. Let's do the one with 0 to pi. So we're going to push 0. And then you're going to go up. Pi is right above, where is pi? Right above the little caret. So yeah, the second, the little caret there, and that'll get you pi. Okay, that's your bounds. And then you put your function in. So we're going to type our function just like it was on the paper. 2 plus sine and then we're just going to put x. So anytime you need a variable, the variable button is right there underneath the mode button. It's at the top next to the alpha. It says x, capital T, theta, n. Those are the variable buttons. That's the variable button. So anytime you need a variable, you push that button. And then we end it with dx. Whatever variable you used, it should be d, that button. Remember, that's the width. That talks about the width. Okay? We're done. Hit enter. We get a decimal, 8.283185, blah, 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 forever and ever and ever, right? What did we get as an answer? 2 pi plus 2. Ours is the exact answer, because if you actually did 2 pi plus 2, watch, I'll do it right now. 2 pi plus 2. See, it's the same answer, right? One's rounded, one's not. Okay. All right. So, I mean, anything that you want to do, you can do it on the calculator. Anything that you want to find, any function you want to find, it's you can do using the calculator. So let's do this one here. Let's try. So clear this. So you can hit clear. If you hit clear, it erases everything on the front page. Okay. Let's try another one. Since we got some time, let's try another one. Let's try this one here. We know the answer, but I want you to try practicing putting different things in there. Okay, so this question here. So it was, I think, C, 1C. It's one of the first questions we did. Try putting those. Since we know the answer to these, we can kind of check our work. So this answer right here. -3 to +3. Okay. All right, so again, we're going to go to math. You're going to go down to integrate, INT. Okay. We want it from -3. So negative, don't use the minus for negative, use the negative for negative. Calculator doesn't like that. Even though negative and minus are the same thing, the calculator doesn't like when you put negatives for minuses and minuses for negatives. Okay. All right, so now we need to put a square root, right? So square root is right above x squared, right above x squared, the square root button is. That's where the square root button is. So you're going to put second, that button, and then we're going to put what it is. 9 minus also, you're like, oops, I typed something wrong. I need to erase that. If you only want to erase part of it, let's say I want to erase this minus right here. I'm not going to push clear, because if you push clear, it all goes away. Then you have to start over. If you only want to erase like the minus, you go right above it, and then you push the delete. The delete is right up here. You push delete, DEL, and that goes away. If you only want to delete part of it, that's what it is. And if you want to insert something, I forgot to put something. Insert, second delete is insert. That'll insert something where you want it to. Okay. Minus x squared. Hit enter. Oh, yeah, there we go. 14.137, blah, 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 blah. Again, we got 9 pi over 2. 9 pi over 2 is the same thing. It's just one's rounded and one's, okay? So this is a way of checking your answer. Desmos does this too. Desmos will do exactly this. So Desmos graphing, it's great. Desmos graphing is great because you can do it on your phone. There's Desmos apps. You can do it on your computer. Desmos is more readily available than these guys. The problem is AP hasn't gotten the notice. They're still on the calculators. They're still using these calculators. We're not allowed to use Desmos on the test. Maybe that'll happen in the future, but for right now it doesn't, so we have to use the calculators. But if you're trying to check your answer, Desmos works fine too. Okay? You're like, I don't have a calculator, but I want to check my answer. Just go to desmos.com. Graphing calculator. And it'll do the same thing. It'll graph it for you, and it'll also solve it for you. Okay? So if I want to do an integral, integrals are, I think they're down here. There we go. Oh, where's integral? There's the function button. I think it's covered right now. Yep, the function button's right there. So you go to functions. You go to scroll down. There's the button I like right there, and go that way and do the exact same thing, and it'll give you the answer. So you want -3 to +3, square root 9 minus x to the second power dx. It gives you the answer right there. Okay. So again, I use the calculators in class because that's what you have to use on the test. It's the only thing allowed is the calculators, certain types of calculators. But Desmos is good if you're checking your homework. It's also the same thing. Okay. So it does all the same features. All right. Alrighty. Okay. All right. Let's see.